All right, example 2 is find the area under the curve with the given information. Here's our function. Here's our interval from a to b. Okay, and here's our subintervals. So there's our n, and it's using right endpoints. Okay, so again, just like I did on the last problem, I think it's really helpful a lot of times to just draw a quick number line. We're going from 0 to 3, and we have 3 subintervals. Okay, so what does that tell us? That tells us, let me just jump down here to our equation. Remember that on the last problem, we knew that we could factor out a delta x because the width of each rectangle is the same on every rectangle. So it's going to be delta x, and then we're going to add up all of our f of x's on the inside here and then multiply it together. Okay? So to get delta x, okay, that's the width of the base of our rectangles, we're going to do b minus a divided by n. So 3 minus 0 divided by 3 is 3 over 3, which is 1. Okay? So that tells me every one space I'm going to have a rectangle. Okay? So if I have, let's call that 1, let's call that 2, that gives me 3 subintervals. That makes sense. There's 1 subinterval, there's 2 subintervals, and then there's 3 subintervals, and they're spaced 1 apart. Okay? So that's going to be where our rectangles are, right? At somewhere above this number line, we're going to have a graph, and we have rectangles. Okay? So let's figure out the height. We don't know the height of any of these rectangles, so let's figure that out. All right? It's telling us to use the right endpoint of our rectangles. Okay, so should I start at f of 0 or should I start at f of 1 for our first rectangle? Well, we're using the right endpoints, so I should be using the right edge of that first rectangle. So I'm going to use f of 1. Okay, and just like in my last problem, I take that value and I plug it into our function. Okay, 5 over 1 squared plus 1 is 5 over 2. Oops, not 5 over 4, 5 over 2. Okay, and then I go to my next rectangle and I'm using the right endpoint again, so I'm using this value right here, so that's going to be f of 2. Okay, 5 over 2 squared plus 1 is going to be 5 over 5, which is just 1. Okay, and then I go to my third rectangle. This is where I'm going to use that last edge. I didn't get to use that on the last problem because now we're using right endpoints. So I'm going to use my right edge, which is f of 3. Okay, 5 over 3 squared plus 1 is 5 over 10, which is 1/2. Okay, and I know my delta x is 1, so if I plug it into my equation, I have my areas equal to 1 times, right, that's my delta x. I just used 1 for my delta x. 5/2 plus 1 plus 1/2. And when I add all those together, I get 4 units squared. Okay? All right, example 3. Find the area under the curve. Here's our function over the intervals 0 to 8, 4 subintervals, but now we're using midpoints. Okay? So again, in order to help us figure out what is our actual midpoints, I'm just going to draw a quick number line. And let's say here's 0 and here's 8. Let's figure out how many spaces there are between our rectangles. So I'm going to say, remember, this is my A, this is my B, this is my N. So I'm going to say delta x is equal to b minus a. So 8 minus 0 is 8 over n, which is not n. I'm going to write 4 because my n is 4. 8 over 4 is 2. Okay? That's giving me my delta x. So that's something that I can factor out at the end. Okay? So it looks like every 2 spaces I'm going to have a rectangle. So what do we have here? 2, 4, 6, 8. Okay, so I'm going to write 2, 4, 6, 8. Okay, so here somewhere in here I'm going to have some rectangles, however they're shaped. I don't really know what the curve looks like. I do, but you don't have to draw it in for these. We just want to algebraically get the areas of these rectangles. Okay, so key on this one is midpoints. So on this first rectangle, am I going to use f of 0 to get the height? Am I going to use f of 2 to get the height? I'm not going to use either one of them. I'm going to use the midpoint, which is 1. Okay, so I'm going to say f of 1 is equal to, I'm just plugging it into this formula, so 1 minus 4 to the second is going to be positive 9. Okay, now I go to my next rectangle. I have a 2 and I have a 4. My left edge and my right edge, I'm not using either one of them. I'm using the midpoint, which is going to be right here, which is 3. So then I'm going to say f of 3, which is going to be 3 minus 4 to the second. 3 minus 4 is negative 1 to the second is positive 1. Go to my next rectangle, get the midpoint, which should be 5. So f of 5. 5 minus 4 is 1 to the second is 1. And I go here. My midpoint is going to be 7. So I'm going to have 7 minus 4 is 3 to the second is positive 9. Okay, I'm close. I just need to fill in my equation here. Delta x is something that I can factor out. I found that it's going to be 2. And I'm going to add 9 plus 1 plus 1 plus 9. Add that all together. So 9 plus 9 is 18 plus 2 is 20. Times 2 is going to be 40 units squared. I did that right? 18, 19, 20 times 2 is 40. I have 8 over 4. Yep, that looks good. I was just double checking. All right. Again, please let me know if you have questions. Your problems are laid out for you. You just got to click on the link.